Okay, so I want to remark on one connection between binomial coefficients, that is these combinatorial combination terms or binomial coefficients, and polynomials. Okay. Okay, so what I'm going to do is I'm going to take 1 plus x and I'm going to put it to some power of some integer n. So let's start with 1 plus x to the power of 0, which we know is equal to 1. Okay, next 1 plus x to the power of 1 is just 1 plus x. Okay, then 1 plus x squared, which is equal to 1 plus x times 1 plus x. Okay, and if I expand this, I'm going to get 1 out of 1 plus an x and another x and then an x squared. Okay, then let's do 1 plus x cubed. Okay, and I can think of that as being 1 plus x squared times 1 plus x. Okay, so 1 plus x squared is 1 plus x. Ooh, I've forgotten my 2. Don't mind me. 2x plus x squared times 1 plus x. Okay, so here I'm going to get a 1, and then I get 2 x's from this, and then from this 1 times this x I get a further x, so I'm going to get 3x. Okay, now let's look at the x squared terms. So I'm going to get 1x squared from this guy and 2x squareds from this guy, so further 3 and x squared this time. And then finally I'm going to get x cubed. Okay, and I could keep on going. I could go 1 plus x to the power of 4, and I can look, that's what 1 plus x cubed is, and 1 plus x to the power of 4 is 1 plus x cubed times 1 plus x. Get 1 plus 3x plus 3x squared plus 1, oh sorry, plus x cubed times 1 plus x. Okay, so then again, if I expand this out, I'll do it a bit quicker this time. We're going to get 1 plus 4x plus 6x squared plus 4x cubed plus x to the 4. And you can sort of wonder how I did this quickly without looking at the brackets. And what you can see is they're essentially taking one row of this times 1 and then one row of this times x. So it's effectively kind of interleaving these terms. Okay, so I'm effectively adding this term to get the 4x here, and this 3 plus this 3 to give the 6 here. That's the effect of essentially expanding this with the 1 here and the x times this. Okay, so what this gives is quite a famous shape, which is called Pascal's triangle. Which you may or may not have heard of. So the idea is you take 1 and you imagine that either side of the 1 is a 0, okay, and then you add 0 to 1 to get this 1, and I add 1 to 0 to this to get 1, and then I draw some zeros at either side, and add this 1 to this 0 to get a 1, and this 1 to this 1 to get a 2, this 1 to this 0 to get a 1. Okay, you can see I'm reproducing the terms in this triangle here. 1 plus 2 is 3, 2 plus 1 is 3, and so forth. Okay, and as we keep on going, we keep on reproducing the same coefficients from expanding 1 plus x as before. Okay, right, so one way of thinking about the way that we expand polynomials of like 1 plus x to some power, okay, is in terms of this kind of triangle shape. Okay. Now, that doesn't seem terribly connected to the counting principles that we had before. But let's think of this another way. Okay, so let's say I've got 1 plus x to the power of 4. Okay, now we could write this out as 1 plus x plus 1 plus x plus 1 plus x, sorry, times 1 plus x times 1 plus x times 1 plus x times 1 plus x. Okay, so let's think about, let's say, the x squared term that comes out of here. So what do I need to do to get all of the coefficients by expanding this guy that have an x squared in them? Well, one way I could do it is I could get the x out of here and then multiply it to the x out of here, then I've got x squared, and then I need to pick up 1s for the remaining terms. Okay, so let's say if I pick up the x here and the x here, okay, and I pick up the 1 from here and the 1 from here, alright, I'm going to get x squared. Alright, now also I could pick up the x from here, the x from here, and the 1s from these brackets. I'd also get x squared. Okay, so that would correspond to this. Okay, so effectively all the ways I can make a term of x squared out of these, expanding these brackets, all the different ways I can label, okay, two black dots and 2 white dots over these brackets. Okay, so in other words, right, it's all the ways I can choose 2 x's out of 4 terms, 4 brackets here. Okay, so the coefficient I'm going to get out of here is 4 choose 2. Okay, further I could do it for the original term. If I wanted to pick up the 1 term, I need to pick up the 1 from all of these. Okay, which happens to be 4 choose 0. Okay, and then 4 choose 1 for the x terms, because I need to pick up 1x, okay, and then all the 1s otherwise. And there's 4 different ways of doing that. I could take this x, and this one, this one, this one, and I could take this one, this x, this one, or I could take this x, and this one, and this one, and this one, or finally I could take this x, and this one, and this one, and this one. Okay. So you can see, okay, that if I expand out these brackets, okay, then we'll get exactly the expressions in here. You can check for yourself quite quickly that 4 choose 2 is equal to 6. Okay, so effectively the terms in this Pascal's triangle, all the terms that we get from expanding 1 plus x to the power 4 are exactly the binomial coefficients. Okay, so this means there's kind of this nice connection between expanding brackets and counting. Okay, and that can sometimes be quite handy in a number of situations. All right, and maybe if you're interested in the multinomials, you could think about all the coefficients I get out of 1 plus x plus y to the power of n as well, and have a think about how that connects to the multinomials that we considered earlier. Okay.